Thank you for the introduction, Vladi, and thank you all for coming to the talk. Just a little bit about me. I've been involved with the project for many, many years now, and these days I work on mentoring and supporting my team at work and in the community. And I've been release manager for several past releases. This is probably important for what's going to come next. Okay. So why this talk? Why? Many of you are in this room. You've come because you've read. There's a new model or driver model which will allow you to extend CloudStack functionality. So why do we need that? For that, we need to understand the current CloudStack dev overview, which starts with anybody who's a user of CloudStack, any kind of development that happens in a community of user-driven features. It starts with somebody needing a CloudStack feature. They would either have an engineering resource internal to their user organization, or they'll hire somebody, or sponsor and support somebody to do that. What they will do is, if you're starting from scratch, you need to learn Java and CloudStack-specific development, how to do things in CloudStack. There's hypervisor, storage, network, how do you build, run CloudStack, all those things you need to sort of learn. And then, once you've had some basic development experience, you would implement that feature as a Java sort of plugin or an API or a service in CloudStack. And after that, you would implement the UI parts, you will add tests, you will add documentation, because you want to then contribute that feature upstream, right? Which means you want to make sure it gets to the upstream release. Why? Because you don't want to fork CloudStack, maybe not always, and you want your user organization to continue to have that feature release after release. And for that, you need to learn how CloudStack community works, how is the contribution model that functions. You have to learn the nuances. You need to maybe build support with people, find the right people, get reviews on your pull request, support on your documentation PR, get them merged. And after it is accepted and delivered, your features are usually delivered through a CloudStack release, right? And then release after release, somebody has to maintain your code or your feature, right? So let's say if your feature is you're a vendor, you have an integration, somebody has to constantly make sure that your feature isn't broken. How do you do that? Well, by the fourth thing, where you write tests, you write component and unit tests and make sure nobody else breaks them. But sometimes your feature gets sort of broken, right? And to do this, you need to constantly engage in the community, be part of the community, part of the releases. So to make sure that your feature sort of stays in there is kind of useful. And then, if I can get the clicker to work, your user organization and other users in the community get to benefit of that feature, right? It's a long process. We have a 6-month release cycle typically. In a year, we can aspire to do maybe 2 major releases, and this sort of cycle continues. And that's a typical developer, an engineer, anybody who's involved in the process in the middle of all of this. But they look more like this, because at the end of the cycle, sort of this becomes this, and it makes you question. Here's the cycle of things, and many of us are involved for the last 10, 12 years doing all of this. Is it something we are happy with? Can we improve it? And there are other pain points with this current contribution model, right? Like you have to maintain across releases. There's a dependency on community. As in, I've done something, so please review and accept my changes, and make sure please don't break my changes. There's the release cycle, which sometimes can be longer than the development or maintenance cycle. Like, I've done my fix today, but then I have to wait maybe 6 months for it to be released, for maybe everyone to get that fix. And people fix it by forking, which means doing private builds, having private branches for the organization, and then maybe wait another 6 months and you release it. And there's lag between collaboration, review, and iterations, right? For example, I've raised a pull request. just like this, there's silence, right? Nobody responds on your pull request. And you wonder, you question yourself, like, am I doing the right thing? Have I done any mistake? And why isn't anybody giving any attention? Why is there silence on my pull request, right? And then you question, how do I build support? How do I get people to, give attention to my thing, what I want to do? And it's the same question for everyone else, right? And then some people get the open source model that, okay, you need to give 2 Fs for others to get 1 back, right? And some people get it, and they are the good community guys. But that's still a pain point for somebody, right, who wants to get things done. I'm a cloud service provider, I'm an enterprise user of CloudStack, or I'm anybody, maybe a small to medium business, or maybe I'm a home lab user. I want to get things done, but I can't, because to get from point A to point B, there's a long path, and it requires patience and commitment to do that. That said, I'm going to iterate and say there are advantages with this model, right? Not everything is what I mentioned is bad, right? One thing is, because things are slow and steady, the things that work in CloudStack, they're more refined. You get stability over a long period of time. And the feature changes in a native code base ensure performance, right? So as long as they're written in Java, it's part of the code base, you get all the benefits of Java, right? With the started code compiling, and once it works, hopefully it will continue to work. We have examples of plugins written 10 years ago, they still continue to function, because whoever refactored code changes, code base changes around it, they continue to get maintained, right? Thanks to Java static code compilation and whatnot. And of course, the community, which has some subset or superset of tests around, or unit tests around that. And then once you have gone through a cycle, once you learn how the process works, how the cycle works, you're more productive next time. So the first PR is probably the hardest. The 10th, not so much. And by the time you have your 100th PR, then you're just part of the gang, right? You know how the system works. And that's true for, I think, any open source project, not specific to CloudStack. And then once your things are being accepted, you have the reputation, you become a committer, you become a PMC member, your contributions ensure longevity, right? You're sort of committed to the project, you're around, people trust you, you have the reputation, and you ensure on a day-to-day basis that your stuff continues to work, right? And there's credibility and longevity to your plugins. So if you're a vendor, if somebody implemented a feature, that there's a length to longevity to aspect to that. And then release after release, the things you've implemented 10 years ago, they continue to ship, right, along with the new stuff. So that's the other advantage I see. Oops. Now, I want to give shout out to some vendors who have figured out like a hack in the process. I mean, you can see Lens Stores plugin, I think, and you can see Store Pools plugin here, where they found that, okay, plugins are shipped as jars. So if maybe I can just ship my jars to my user organization or customers or whoever, right? And that's how they do it, right? Like it's just a jar file. So if they want to ship changes early to a customer, they can just ship a hot patch or a jar to their customers and users. So yes, there's a workaround, but may not be pretty, because you're sort of forking, and some users may prefer, may like, some users may not like that. So there is some workaround, right? And it applies to CloudStack generally. A lot of people maintain a fork of CloudStack. They'll continue to work on features. They have their private packages. So they figured out how to consume, how to be a good community citizen, but also how to continue to work on those sort of features. Can it work? Yeah. Taking a step back, that's what you want. You want to, okay, it's failing all of us in the room. Basically, what you want to do is you have a feature, you want a feature in CloudStack, and why do you want a feature? Because there's benefit out of that feature, right? And the question is, can there be something that I can make to solve my problems right now, maybe tomorrow, maybe end of this week, but not like wait for 6 months, and using my existing skills. So if I'm an SRE guy or ops guy, maybe I know shell script, maybe I know Python, maybe I'm a new college kid, so maybe I know Go or SDK or, the Rust or whatever is the new JavaScript variant has come in the market, right? The question is, I have my skill set, I know programming, CloudStack contribution model sort of patronizes you because you need to learn a lot of things. So it's not like I'm a stupid person. I know my skills. Can I use them, please? And that's the kind of question I all would ask, right? And I would interact with a lot of you over the years. Some of them are my customers, users in the community. And I'm like, can there be a model, maybe a new sort of driver model, which will allow us to do that, which is get to point A, from point A to point B fast? Because many of the people may not want to contribute changes, right? I want to fix my problem, and sometimes it's just my problem. I don't think everyone else would want to do things in this way. And CloudStack sort of gets in your way. And there are ways to do that, right? One way is anybody can say, oh, why don't you write your own plugin in Java, right? Or have like a thrift interface or something, right? There are millions of ways to do this, solve this problem. That said, any kind of complex system or plugin model you introduce, which means people will have to read something, and documentation is the last thing developers like to write and read. The writing part is also an issue as much as the reading part. So nobody wants to either read the documentation or write one. So I thought, let me look at the CloudStack architecture diagram and look at, okay, what are the things maybe we can do around it, because the CloudStack architecture hasn't changed in the last 10 plus years, which is also a good thing, also a bad thing maybe sometimes. And I thought, okay, there are some areas which I'm not going to talk in this slide, which can have some benefits. To understand them, we need to understand how the CloudStack how does the CloudStack, the whole sort of CloudStack world work together? It starts with users on this sort of left side, which call an API, and there's a bunch of things. The control plane, we call the management service, which uses database, the MySQL server. And then there's something in it, we call plugins, that talk to these various third-party systems. Your hypervisor host is a third-party system. Your storage, your network, all those things are external system. And every plugin has its own unique way on how they talk to each other, right? Every hypervisor, every component system has its own way how they talk to each other. So there's no uniformity. So what can we do to simplify this? So I had to look into the just API workflow, right? How does a CloudStack API actually run? It starts with an API request being handled by what we call the service layer and what we call the CloudStack kernel. And it does something. It will send sort of a command to a plugin or a resource, right? And that resource knows how to talk to that external system, whether it's hypervisor, network device, storage device. That's more or less how a typical workflow of an API. And I was still thinking, can there be a meta framework? Jokingly, internally in my organization, I would say, can there be a mother of all plugin framework? Almost like insulting CloudStack, right? So I thought, let's do a SWOT analysis, because that's what you do, right? So I've got a sort of two axes. On one side, we have performance. The other side, we have complexity. Let's see if it works. It will be more dramatic if I do it like that, right? Okay, maybe like this. So I thought the current CloudStack plugin model, I would say it's highly performant because it's part of the JVM, part of the software, and you kind of, in the thread of execution, not a separate process, you execute operations when an API is called, but it's complex because all the things we have covered so far. And there is a new thing called webhooks, which allows integrating and consuming events from CloudStack. So CloudStack events are consumed and can be called to a third party, it can be handled by a third party HTTP endpoint, a web service, for example, where it can do something. So when a VM starts, or account logs in, a network is created or programmed, or network shuts down, a template is created, you can do some hooks or some features around them. But then where are the gaps, right? So we can see there are 3 gaps I can see. The first one is you can have a lowly performant, complex feature that requires a lot of time and effort, it's very complex, but it gives you low performance. Maybe that's not what we want, right? You can have very high performance, but there's some feature which is easy to write. Maybe that's an interesting bit to explore, right? Something that's simpler, like a mechanism, a way, a approach, which is like you can easily implement your feature, and it will be highly performant. Or the sort of other option, which is it's simple to write, but not very performant. And I think the two gaps on the right side is probably where we can think about and explore if there's something we can do about it. Why? Because you probably don't want to do it in a complicated way, because wherever there's complexity, there'll be documentation to write, there'll be workflows to learn, and things that people don't want to do, right? So we want something that's simple, and we are happy if the performance is a bit slow, right? Something that just gets out of my way, so I can iterate faster, and then of all the 100 experiments I'm able to do with CloudStack, maybe the ones that I really want, those I can like polish and refine and put my time and energy on. And then maybe you want to also implement things which are not complex in CloudStack. So maybe VM orchestration, CloudStack already does that. Most people don't have a problem with VM orchestration. They want to do stuff around VM orchestration, like before a VM starts or after, things like that. Somebody said, I need a feature in the hackathon. I need a feature to rewrite the domain XML because I want to add GPU or devices and what have you. Something very simple like that. So can we have not very complex features? And the last thing is, who is this for? I think this is not for your typical Java engineer or Java developer because they know how to do the other quadrant, the current mechanism. It's mainly for people who are admins, sysadmins, SREs, ops, people who know Java, who maybe not know Java, sorry, and maybe well-versed with shell script and Python, any other kind of executable, right? And they want to implement something very simple. And I want to give a shout out to Hari. Where is Hari? He just gave a talk earlier before with Alex, and they implemented a really nice feature. It's called External Deployment Integration in CloudStack. What this feature does is something, I thought I'll give a shout out in this talk because it allows their feature allows users to write a shell script which can orchestrate any kind of workload, external orchestration system with CloudStack. It's keeping very simple. What can you do? You can start, stop, list, create, and destroy things. What things? You decide what things. You want to integrate Proxmox, integrate Hyper-V. You want to write a shell script where every time you deploy an instance in CloudStack, a coffee comes in, you can sort of do that, right? So I love this feature, and I think shout out to him and Alex and Hari who designed and implemented this feature with Alex and, of course, rest of the community. So I was thinking, what are the things where, I think I've identified the gaps, but where are the gaps in code? Like, is there a way to do it? And I think I found anything in, slightly technical, anything in the CloudStack code base that implements an adapter or adapter-based, abstract class or interface is a plugin. And all those plugins have methods. Those methods have some inputs, and when you execute those methods, you get an output. So I was thinking, can we find all such plugins in CloudStack and also crowdsource ideas from the community that what are the things you guys want to do? And then think, okay, what are the kind of add-ons or extensions you can do in CloudStack, which wouldn't require you to, let's say, restart or compile, build, and run CloudStack. It's just there. And you can just iterate by using your existing skills, which means anything that you can write in, a shell script, a Python script, a compiled Rust binary, Go binary, what have you. And here are some examples of what I think people can benefit from. Simple thing like user authentication. What are the inputs? Username, password. What is the output? Whether authentication happened or it didn't happen, right? And other things I mentioned, like I'm creating a network and I need something which can execute, let's say, shell script or a Python script which programs my switches, like adds a VLAN, something very simple like that. Or like some gentleman said the day before yesterday, ability to rewrite the domain XML for libvirt. Slightly more complicated, but that's the kind of use cases people want. So that brings to the idea of CloudStack extensions. What are they? They're basically, it's like in any kind of executable. It's a Python script, shell script, is a compiled binary, which you put on the CloudStack management server. You execute by forking out a process. You give it some parameters, std in, arguments, flags, and in return you get standard output, standard error and exit code. That should be enough to create some sort of mechanism where CloudStack can talk to your extension and back. Here is an example. I want two-factor authentication, and let's say, what do we do in a two-factor authentication? Which means somebody is already authenticated, you need some sort of OTP or TOTP, and maybe user context, like which user is trying to do like two-factor authentication. You can create a script. In this case, let's say a Python script, right, which is custom logic, which can, let's say, send you an SMS or a WhatsApp message and whatnot. And users can send you back the code, and this script will simply say that, is it the same code that I sent on an SMS or a WhatsApp, right? And in return, it can either send print something, which gets captured as std out, or send an error, which can be used to send a message on the UI when somebody logs in, and an exit code, which in this case is very simple, right? If it is a 0, which means you pass, and if it is, I think I switched it, so 0 would mean normally pass. If it is a non-zero exit code, which means it is a failure. And that brings me to another idea. Once people can write extensions, maybe we need a store, some way where in the UI, I, as a root admin or a sysadmin of CloudStack Cloud, can tell CloudStack where my extensions are. I specify the path on the management service, enable and disable, have a button to test, like before you enable it, maybe you want to test and say it works. And also, maybe some tool mechanism where these power users of CloudStack, right, the admins and sysadmins and SRE ops people of CloudStack can use scaffolding. What is scaffolding? Creating a boilerplate, a starting point. People love a starting point which can be generated by, I would say, an LLM model or maybe some clever coding. And then you can have metadata, you can specify some information about your plugin, and allow users to export your plugin, import your plugin, share it around. A GitHub-based distribution model could be explored. A community that can learn and adapt from each other. So if there are thousands and thousands of people in the community, one person can come up with a nice extension, share with others for others to benefit, edit it, reshare, distribute, much like you see extensions on a web browser, for example. And I think the next steps can be, the first step was for me to build support with all of you through a talk. Maybe we go ahead and discuss on the mailing list where we take it to the next level. Hari and Alex's work, Hari's work in the design and implementation of the feature gives us a good idea of what is possible through this extension mechanism. And we iterate on the interfaces. How does CloudStack perform I/O with your extension? And gather use cases. Ask people, what do you want to implement? And some of the answer can be, oh, you can't do it with an extension. But many of the answers can be, yes, you can probably do it with an extension. Or this is a really good idea to have an extension, a mechanism that allows you to do something simple, like the examples we have gone through, and develop, test, iterate, and repeat. And that's my talk. Thank you.
Thank you, Rohit. Do you have questions?
So Hari's question is, are there any extensions I've tried? The answer is yours. Do you want to see a demo of your extension?
Do you actually see a risk of, well, a lot of people doing their stuff then suddenly on their own, in their own lab, in their own environment, and not sharing that with the community anymore because it just works for them and that's enough?
Yes.
Well, as much as I like this feature, I see a risk as well. And the same risk with quality. You mentioned the first idea which came to my mind, that it requires a space where all those plugins, where we can simply share them with others, but the code quality will probably not be the same anymore as it is with the Java plugins, right? So as much as I love it, love to see it, I see a risk as well. That's
absolutely
somewhere in between.
Yeah, I mean goes to my slide where I talk about the pain points, but the advantage of the current community workflow we have. I think there's no one-fit solution to this as I think about it, right? A lot of people wouldn't want to care because CloudStack gets into their way of what they want to do, and a lot of people still have plugins written in Java just local to their environment because of that. Or somebody's on a forked version of CloudStack because it just works for them, it's boring. And I think my opinion has changed in terms of we should recognize that CloudStack community should empower all kinds of users. Somebody who wants stability, code quality, longevity should take the hard path. But somebody who wants a quick win should be allowed to take an elevator and go to the top of the mountain, right? And still take a photograph and tell people like, I hiked, right? So.
I'm interested, how do you envision being able to hook it in so that yes, we want to execute this thing, but how do you find a way to maybe it's webhooks or something like that, but how do you inject it into the call path in a sense on this is something that
you want to see Hari's demo? I don't know.
I haven't seen it, no, sorry.
Okay, so maybe after the talk is over, if you guys want to look at that, I can just show a quick demo of Hari's feature. The way you do it is you have to come up with some sort of communication pattern, right? In this case, the idea is there's a verb, there's a payload. There's a method, there's payload to that method. That payload to the method can be a JSON or some sort of serialized format. So, and the method is something, so let's say in this case, it's starting a VM. So the verb is reserve or start or delete, something like that. And there's a payload, which is JSON. And when you call an API, you can pass details to such an API. So you can send arbitrary parameters to your extension, think in this way. And as in response, you can again get a JSON, a serialized format that CloudStack can interpret and make use of that. So I'm happy to show you an example after the call, in person, or if everyone is interested, show it on the screen. But here is a good way to learn, okay, how this can be done and achieved. And maybe we iterate over that and do, okay, let's take a step back. It's done it for orchestration of extension that integrates external orchestration in CloudStack. How can we do for other features in CloudStack?
Okay, more questions?
Will this new method will be available in 4.20? And will be there a list of available entry points or whatever is the proper term in CloudStack for extensions, where you can plug extensions?
Yeah, so Hari's work on the extension will come in 4.21 with some iterations. And this whole idea of a CloudStack extension framework, which allows you to write extension, may come in 4.21 or 22. So that work for the broader extension hasn't even started. As I said, this is the first step for me to propose it. And Hari's project around adding external orchestration through extensions in CloudStack is the first step to do that. Yeah.
Okay, anyone else?
Let's do a demo, right? What can go wrong? We have 10 minutes, right, before?
2 minutes, actually. And then we have 20 minutes of coffee break.
Yeah.
Maybe you might use them for a demo.
We'll try. Can we do it in 20 minutes?
Can you fit in 2 minutes?
Yeah. If I can do it in 20 minutes, that means this thing should have potential, no? Okay.
A new plugin for 2 minutes for the first time.
Yeah. 2 minutes demo. Here we go. So I'm not going to show the shell script, but there is a script which is going to put stuff in the log file, that's it. So the way it works is, on the infrastructure level, you create a cluster. Sorry, Hari, I'm just going through your demo. You just say, I want an external orchestration system, which is this particular, okay, let's just pretend we haven't seen that, right? This sort of customer name. And then once you've created a cluster of that type, you just select that cluster, feed in whatever values you want, and then you go to the images, you register a dummy template, of that type of external orchestration system. And then what happens? You go to compute, go to instances, and then here you select the dummy template, which correlates to the external orchestration system, and then you select all the network, all the parameters. You can even give some custom values. So let's say, since Will asked this, so I'll say name is Will, right? And then I'll say Will demo, and then I'll launch the instance. What happens is, this is the shell script trying to execute the reserve method or reserve parameter, and there's some API payload, and then it's created this. Voila, you have an instance in CloudStack which is not running, which is running in a shell script basically, right? It's called Will demo, and that's the 2-minute demo. Isn't this exciting? And imagine your shell script can automate an external switch, a storage system, instance on Proxmox, OpenStack, Hyper-V, AWS. So it's endless what you can do with that. And then, of course, I can click on delete, and the shell script will be asked to handle the delete operation, right? It will be given some sort of payload and whatnot. That's the demo.
Thank you.
So shout out to Hari. He did the work, of course, along with others in the organization, in the community. I'm just the person who's just showing this. So thank you very much.
Thank you.